Okay, welcome back to J Squared Manufacturing Design. We're touching on injection molds again today. I'm learning as I go on these YouTube videos, so any direction is nice to have. Today we did just complete the split. We've got our components split out. We've got our parts there. Now we need to prepare our blocks for things like water and other things. So we know that there's going to be a pin right here in these 8 locations. We have the pin diameter called out. We want to put a sleeve around this pin, which is basically like a form of ejection that moves. The pin stays stationary and the sleeve moves around the pin to push the part off the boss of the pin. That's important for pins because the plastic part tends to shrink around the pins when you use when they are in that configuration. So you want a sleeve wherever you have a pin, if at all possible, or else have good ejection in other forms. Honestly, with this part, we may be able to get away with just a few other ejector pins to eject this part. So the first thing we do is go ahead and put these sleeve holes in this block. So the first thing we do, we have our mold volume for our pin. We need to create a mold component for that pin. Select all these things. Copy our start part so it'll bring in our correct information. And OK. Now we have our core pin, our core, and our cavity. So we're looking at our core. So we open that up. You can see it needs to be regenerated, RG. Now it has a hole in it. So in that hole is the whole diameter of the pin, which is 250. So what we need to do is we need to go to dme.net, go to their e-store, go to pin sleeve blades and components, go to ejector sleeves and sleeve extensions. We want nitrided OD and ID. Now we're going to look at the product catalog page. So we want one that has a 1/4 inch OD ID. 1/4 inch ID. Okay. And then we have our choices on we don't want to go oversized. So we're at 3/8. We want a 3/8 hole there. If you go to 380, that's if like the hole, if you're repairing a mold and the hole is wallered out and you need to increase the size of the hole to clean it up, so you use a 380 sleeve in that case. So you do not want to go to a 380. Immediately you want to go to the 3/8 first. So we have a 3/8 pin there, or sleeve. So we go back to our mold, and we're going to sketch on the backhand side of the block. And the reason we're sketching on the backhand side of the block is because, and we're going to grab these references to where these holes are, is we're going to put a hole with a clearance hole. You don't want to have to drill a 3/8 hole all the way through a 3-inch thick block. You're just not going to get a precise hole. It may wander. It may not be straight. There's a million reasons why you don't want to drill a 3/8 hole all the way through a block. So what we do is we come in here and we put a point on every center point here. Confirm it. Now we put a hole in. We make it 0.375. Then we go to standard counter bore. So we're creating a counter bore, but it's not really a counter bore. It's really just a larger diameter hole that's easier to drill. So we're going 406, which would be 15 thousandths. 15,000 or 30 thousandths over a, actually we shouldn't be 406. $390, that would be the correct one. So then we're going to make this through all, and we're going to kind of play with our, you can see our depth right there. We're going to go, we want it to be about, we want our bearing surface to be about, oh, this is not going to work. Ooh. See my problem here. Let's go ahead and confirm this here. Let's make this 0.5, so we have a little bit of bearing surface there. Now you see that I've cut up into my surface there. So if we copy this surface, there's where this little this thing is, this boss is 2 thousandths too small for this ejector sleeve. In all likelihood, and since this is just an example mold anyways, we're gonna go ahead and pretend like that's okay, and the which it's a minor deviation, customer approval would be required, but you may be able to change the size of that boss and increase it by 2-3 thousandths so that it, you know, in the part design. We're just gonna kind of carry on because actually no, we're not gonna carry on. So let's say we can increase we've asked our customer, we can increase the size of that boss. So what we're gonna do is we're gonna go back into SolidWorks because that's where the original part model was from. Remind me later. And of course it takes forever to open when I want it to open immediately. It's got to load in all its crap. There we go. Now I open up this part. So it's this extrude right here. Now, what we'll do is we'll make these construction. We'll draw a circle larger. We'll set all these to be equal. Then we will change this to 0.380. Messing with our wall thickness just a little bit, but it's not going to be a game changer. It's it's not gonna ruin the part. And my rib failed. Great. Can you let me do it? No. What's that? What's that? What's that? I'm tempted to be a bad part designer because technically these all still work for what we're trying to do, but they don't. It's not. I got blue, and blue drives me nuts because blue means things have not been constrained, and that means that you could be working with something that may be not what you're intending to work with. That won't work. Okay, so up here. Oh, and this is because I can't use the. That's the one thing about my channel is I'm not going to show you things that work perfectly every time. I'm going to mess things up somewhat on purpose just to prove a point that, you know, just because you'd like for a split to work out the first time or everything to work out the first time doesn't mean it does. And when it doesn't, you need to know how to fix it. So that's kind of what this is about. There, I fixed all my references. There, now I've got my part. So now I need to file, save as, housing, 1/14/23. Save it back into the mold file. As a step. Okay. Then we'll save this. Now, if I did this correctly, should be able to open up my copy assembly and then assemble all files Housing that. Should be able to go to default. There we go. Now drag this before my copy because I have to have order of intent here. And really depends on how I want to do this. So I think what I want to do is I want to try this because this will create the least amount of problems with my split. So I'm just going to copy the surfaces that have changed. You can see here this is where this is larger. So I'm going to do that, and then I'm just going to solidify. And it's not going to work for it. Oh, did it work? It worked. So now we have, let's change some colors here. Now we hide our original, and now we overlay. So there we go. So we save this, generate this, save this. We'll open up our split, we'll regenerate our split, shade it, wireframe it actually. We come in here and we look at our hole and see, look at that hole, it's just a little bit bigger. Got a little bit of flat there. So that was a success. So now that we've got that hole sorted out, I'm going to take our hole, which, let's check our land surface. So we want about 5/8 inch and a half of land. So that's a 3/8 sleeve. I want 150% of land, so I want 188 plus that. Math is being hard right now, like a 563. So I'm going to go into this hole, shape minus 0.1875. Now, model, pattern, point, there. Now I've got my holes everywhere. So the reason why I do those first is that those can't change. Those have to be where they are. Everything else, ejector pins, pretty much everything else, can be moved wherever it needs to be moved if we have something in the way. There's one other thing that we do have to place, and that is the gate. Now on this one, since it doesn't have a real good place to gate it, what I figured we would use would be these PCS mold components. These tunnel gate inserts. So in the next video we will go through putting these in and how to orient them and use them, and go a little further into that. So If you have any questions, leave them in the comments.